In 1905, Einstein extended Planck's quantum hypothesis to light. He argued that when light is emitted by a molecule, it has to come as a packet of light energy that equals to hf, because an oscillator's energy can only decrease by a whole number times hf at a time. He called the packets of energy photons. Each photon of frequency f would have an amount of photon energy that equals to hf. Now let's try this problem. A 405 nanometer violet laser light has an output power of 5 milliwatts. A. How many photons are produced by this laser every second? B. How many photons can be found in a 5-meter long beam at any moment? For part A, let's first find the energy of one single photon, which is E equals to hf. Now we were given not the frequency but the wavelength light. And if you remember back when we learned in the waves unit, we have the speed of a wave equals to frequency times the wavelength. So for the speed of light, now this is c equals to frequency times the wavelength. So the frequency would be c divided by the wavelength. So this will be h times c over lambda. We're going to use the h, that is the standard unit, because watts is the standard unit. So h is 6.63 times 10 to the negative 34th times c, which is 3 times 10 to the 8th, divided by the wavelength 405 nano, which is 10 to the negative 9th. So if we do this calculation, we'll get the energy of one single photon is 4.91 times 10 to the negative 18th joule. Now we want the number of photons produced every second. Let's see, we have power, and we know that the energy in 1 second would be, energy is power times time, so that would be 5 milliwatt times 1 second. So we get energy output that is 5 millijoules. That's the total energy produced by this laser beam. And we want the number of photons. The number of photons will be the total energy divided by how much energy each photon can provide. If we divide the total by how much each provides, we can get the number of photons. So the total energy is 5 milli 10 to the negative 3rd joules. And every photon would contribute this much energy, 4.91 times 10 to the negative 18th. That means that we get 1.02 times 10 to the 15th that many photons. Now part B, we want the number of photons found in a 5-meter long beam. Now in 1 second, we have this many photons. And in 1 second, the laser beam can travel a distance c. That's 3 times 10 to the 8th meters. So if we look at in 1 second, we would have 1.02 times 10 to the 15th photons in a beam that is how long? 3 times 10 to the 8th meters, because that's the distance light can travel in 1 second. So we have 1.02 times 10 to the 15th photons in that length. How many photons can we find in a beam that is 5 meters long? So if we do cross multiply and then solve for x, we will get x is 1.7 times 10 to the 7th.